Alright, what's up guys? Mr. Fabella here. This is going to be the first lesson of the new chapter. We're going to start off with circles and circumference. So it seems like it's just one thing, but we're going to go over the parts of a circle, what makes up a circle, and solving for the diameter, the radius, and the circumference. Alright. Okay, first of all, let's look over some of the vocabulary we're going to learn today. Circle, center, circumference, diameter, radius, and then finally we're going to find out what pi actually is. So the actual definition of a circle is the set of infinite points equidistant from a center point. Now equidistant means the same distance from one point. So here I'm calling this circle O, and O is the center. So the circle is the set of infinite points that's the same distance from that circle. Okay, so here we have these, and all of these points here are the same distance from O as all the other ones. Okay, so now radius is defined as the segment or the distance from the center to the actual circle. So the radius is a line segment, and it's OA right here. So from O to A, that's the radius. But when we're talking about geometry, a chord is a segment that connects one point on a circle to another point. So in this case, XM, I could make, this could be a chord, this could be a chord, just one point on a circle to another point. So like even like that right there, from there to there, like from here to here, there to there, that can be considered a chord. And then finally, diameter. So diameter is actually a chord. So remember, a chord is a segment that connects one point of a circle to another. It's a chord that passes through the center. So in this case, XY is a diameter. Okay, so another diameter could be from here to here as well, or from here to here, as long as it goes from one part of the circle to another part, and it also passes through the circle. Okay. And because of this, since you're going all the way, so like let's say I'm going from MO to OA, the diameter is actually twice the radius, because radius is from the center to the circle. Well, this is from the center of the circle here, center of the circle here, that's two of those. So the diameter is actually 2 times the radius, is half of the diameter, which makes sense, because if you said, I already said the diameter is 2 times the radius, if I want to solve for radius, I could divide by 2. So the radius is the diameter divided by 2, or 1/2 of the diameter. So let's do some quick examples here. The diameter of the circle is 14 inches. Find the radius. Well, we already said that the radius was the diameter over 2, so the radius would be 14 divided by 2. So the radius would be 7, and then in this case, inches, not inches squared or anything. We're not talking about area. Okay, here it says this radius of a circle is 8 feet. So find the diameter. So diameter, we said, was 2 times whatever the radius was. So if the radius is 8, this is the radius, diameter equals 2 times the radius. So diameter is 16, and in this case, feet. Okay, so now we're going to look at the relationship between diameters and circumference. The two easiest things to measure on a circle are the diameter and the circumference, because you can just take a tape measure and measure all the way across, or you can take a tape measure and measure around. It's very hard to measure the radius, because what if you don't know exactly where the center is? So those are the two easiest things to measure on a circle. So, and I have some examples of my favorite circles, which would be vinyl, like record albums. So here are a couple of my favorites. The one that you saw the intro is Sufjan Stevens, Carrie and Lowell. That's amazing. This one, if you're not familiar, is Random Access Memories by Daft Punk. Pretty much a modern classic, I guess. You know How to Keep It Real, Wu-Tang, Legend of the Wu-Tang, greatest hits. Good stuff for me, at least. That's what I grew up on. And then probably the first album that most people get is Miles Davis, Kind of Blue. Kind of Blue. So let's look at that one. That's my favorite one. LPs, long play or albums are 12 inches across. They're called 12-inch. So that means the diameter of this is actually 12 inches. So that means the radius from the center to the edge over here should be about 6 inches. Okay? And then we can actually use that to find their circumference. But before that, we'll talk about the ratio of the circumference. We can measure the circumference, measure it around, and we can also measure the diameter. Maybe I'll put that up here, and put what the ratio of this specific album is. All right, so let's look at other examples. I'm going to put this album away before it gets scratched up. Those were my examples for some circles. So let's look at some of these relationships between diameter and circumference of different circles. Here, a silver dollar, measuring around it is 12 centimeters, and across is 3.8 centimeters. If you took the ratio of the circumference to the diameter, if you took the circumference divided by the diameter, you would get 3.1578. All right, it's fine. Let's look at something else. Let's look at a compact disc. Probably don't see many of those. Probably I see more LPs than compact discs now, maybe even more than Blu-rays, just because I like them. So, but if you take a tape measure, the diameter here is 12 centimeters, and the circumference is 37.7 centimeters. And if I took the ratio, divide circumference by the diameter, I get 3.146. You're probably seeing where this is going, but I'm going to do another one. I'm going to take an even bigger circle, so a tabletop. We'll say that's 20 centimeters across, and then the circumference is 628.3 centimeters. If I did the same thing, I took the ratio of the circumference to diameter, I would end up with 3.15. So what do you think that is? So regardless of the size of the circle, the ratio of the circumference to the diameter remains constant, meaning it stays the same. No matter how big the circle is, it's going to be this number, which is pi. So circumference over diameter, if you divide it on any circle, it's going to be pi. So maybe you're thinking, why isn't this pi? Why isn't this what I'm used to? Just because you cannot measure the circumference of a silver dollar as accurately as you can a tabletop. We know now that the circumference divided by the diameter equals pi. So how do you get the circumference of a circle if you don't know it? Here, it looks like you have the circle. What if you only have something straight to measure with? You only have a diameter. You want to know what the circumference is. So since pi is always going to be the same, we can actually use this equation that we found out to find the equation for the circumference. So if I want to get the circumference by itself, it's being divided by d. To get circumference by itself, I'm going to multiply both sides by the diameter, like that. You can cross-cancel the d's, and now I'm left with circumference on the left side, which means circumference equals pi times the diameter. And if we remember from before, we said earlier that the diameter is 2 times the radius. So another way to also say this is circumference equals pi times, well, we said it's 2r. So instead of diameter, I could say 2r, or you're probably used to seeing 2 pi r. So we have these two, and they mean the exact same thing. It doesn't matter which one you use. One is given the diameter, one's given the radius. As you can see here, so let's do an example, a simple one first. Find the circumference of a circle with a diameter of 7 inches, and it actually says use pi is approximately, so it's using that symbol, approximately 3.14, because it doesn't equal 3.14. We're just going to say it's about that. Okay, so it's usually going to say what it wants you to use, whether it's 3.14 or some other number. Okay, so let's rewrite and just fill in what we know. Circumference, we don't know. Pi is 3.14. You can use parentheses. And the diameter is 7 inches. So then 21.98. So I'm actually going to correct myself. It's not equal to 21.98. It's approximately 21.98 because we approximated pi. And then inches. Okay, here's a word problem from the book as well. John's making a circular table that has a top with a diameter of 24 inches, so he measured the top. What's the circumference of the table? Round to the nearest tenth, so in case he needs to get material for something to go around the table or something, right? So here, it's giving you the diameter, so we know the circumference equals pi times the diameter. So circumference equals, it doesn't tell you what to use for pi, so I'm just going to say 3.14, and the diameter is 24. Let's multiply that out, you get 75.36 and inches. Not inches squared, we're not doing area yet. That's next time. All right. Okay, so it's then finally a kind of harder problem. This is from an Alex problem. A rose garden is formed by joining a rectangle and a semicircle shown below. So a semicircle is half of a circle. The rectangle is 22 feet by 17 feet. The gardener wants to build a fence around the garden. How many feet of fences are required? So that means he wants to do it all the way around the garden, which means it has to go around this part. This part is not, you don't need fence around there, but you do need fence around the semicircle. So this is going to be multiple parts. So let's try to tackle this. All right. So the easier part here is the rectangle. So let's worry about the rectangle first. This is 22 here, 17. If it's a rectangle, that means this is also 22. Okay, so the perimeter would be 22 plus 17 plus 22 plus whatever that semicircle is, plus the semicircle. Okay, so let's try to find that. If you know that the semicircle is half a circle, you get the circumference, right, is equal to pi times the diameter. And then, so the semicircle is going to be 1/2 of that, because it's going to be half of the actual circle. Okay, so let's see. Pi, we'll say 3.14, because that's what it said to use. The diameter, it doesn't say what the diameter is here, but 17 feet over here. This side of the rectangle is 17 feet, but that's also the diameter of the circle. So that's my diameter, 17 feet, and then times 1/2. All right, so you could use a calculator for this. This is 3.14 times 17 times 0.5. So 1/2 or 0.5, and that's going to be 26.69 feet. Okay, and it said do not round your answer because it already said to use 3.14 as pi, so that's kind of rounding your answer already anyway. All right, so 26.69 feet is how much fence he would need. Obviously in the real world, he would probably go ahead and buy 30 feet or something, but it's good to have an estimate of how much material you would need. All right, so hopefully that was helpful for finding the radius, the diameter, and the circumference. And I'll see you guys next time.